we present LightMap Fusion Pro, a comprehensive solution for managing static lighting in Unity. It provides a set of tools that efficiently combine light maps, skybox, fog, and reflection probe, making it easier to use and optimized for performance, especially on mobile platforms. It is particularly beneficial for projects that require lighting modifications or seek greater control over the quality of static lighting in the scene. Let's proceed to explain the functionality of the previously introduced LightMap Fusion tool, and for that, we have created this small scene, which will allow us to demonstrate how to use the tool and how to configure it. The first thing we will do is come to Windows, open Tools, LightMap Fusion, and initialize the tool. Once there, we will create the LightMap Fusion object, which features this interface. It is important to say that if we have not previously saved the scene and have not created our light settings, then when selecting the tool, it will appear in this way and allow us to create our own light settings. Either select or create them here. We are going to use some that I already had created for the scene with my configuration. It is important. If we have a powerful graphics card, select GPU because it will do it faster. And now, we proceed to explain how the tool works. Okay, the tool has two working modes. In mode 2, it allows us to interpolate between two lighting states, and in mode 4, it will allow us to interpolate between 4 lighting states, which are controllable by these sliders here. The tool has its own shader system and its own materials. Therefore, we have created a material conversion tool, which will allow us to detect the materials in the scene and convert them to the type of material of the tool. It is important that for the materials in the scene to be detected, they will only be the materials that need light map, which are the static materials, or those that contribute to global illumination. That is, in this case, we already have our scene materials selected as static. Therefore, once we press the button, Search Scene Materials, it will find all the materials in the scene, and we can tell it to convert materials or reverse the process if something went wrong. Once this is done, we can go to LightMap Fusion and tell it to load materials from the scene. That's all the materials that have been converted. It will detect them and load them. So here, if we go to the materials, we realize that the materials are already of the type only LightMap Fusion, only shaders, which are here. And he will have done the conversion. Here we have different types of materials that we provide to facilitate use. Once this is done, we come and verify. Let everything be fine. Importantly, that all the textures we have assigned are maintained. Here, in this case, we need this material to be transparent. We comment because the conversion is done to the most suitable material type. Here we change it to transparent. This is for materials that reflect as an optimization. We have a type of material called matte cap. We have here only shaders of mask fusion. We are working on a universal render pipeline. Otherwise, we would use the materials from here in URP and matte cap. Okay, we have our markup material. All good. Here in the light sets, as I was saying, we have available 4 light sets, which are configured within the tool and to which we can refer from here. And we had already created it beforehand to save time. So what we will do is, here, we place these lights in light set 1, these lights in light set 3. 2, you are in light set 3. These lights have been previously configured as lights that are not real-time, but contribute to the lineups. and the lights for here. These ones here, or these ones here. We remove them. If we come to the tool, and these objects refer to our slicer, which means they can also be others. Other specific objects are simply containers. But when we come here, they allow us to activate each of our light sets in the scene. If we were working in mode 2, we would simply work with 2 light sets, but at this moment, we'll do it with 4. Here we have some debugging tools if we want to calculate the lighting in a specific set as we use this debugging tool. We will move on to configure our environment. Why? Because the tool also provides specific skyboxes that allow us to make interpolations between the different lighting states. Okay? That is, for example, transition between day and night. So the environment needs to have different intensities, even different hues. It can work in mode simple, which would only be a skybox with tint colors, interpolation between tint colors that we can specify here, or in a complex mode, which allows for interpolation between different skybox Q maps, to say it correctly, and also the tints. We are going to proceed to create our material, so you can see how it works. So we create our skybox. Here we are going to replace it with one already existing. For example, here we had one created. We tell him that we are going to replace it. Yes, it says that our skybox has been created, and here we have the skybox. Let's proceed to set it up. We're going to choose from our Kigo. I think this one would be fine. And among our lighting states, we'll start configuring. Here we say set skybox, and for example, here I would want this tint for state number 1. Then there will be coherence between the states. In this toolbar, we can see each of the states in number 2. Well, we make it more yellow like this. Number 3. This, if we turn on the lighting, we can see. In state number 3, a little bluish, quite dark. And in state number 4, already practically black, because it will be a very, very dark scene. Okay? So if we move away, we see that between the different states, the lighting we have in the first is daytime, second like a sunset, the third at night, and the fourth, if we move the controllers, we see how there is interpolation between the states. Once this is configured, we proceed to create our reflection probe. We create our reflection probe. This is a specific reflection probe for our tools, as it allows us to perform interpolations between recalculating the reflection, the Q map, but only when we need it, when there are changes in the states, and not constantly doing it. This is set in the tool. In the tool, if we mark dynamic reflection proof, and the update rate, the higher it is, it will look less fluid. For now, we have only set 1 for the sake of maintaining the tool's performance, but we could extend it later. The more reflection proof of this type. Okay, now we are ready to calculate the lighting of the scene. We can select the resolution at which we want our light maps to come out. Alright? In this one, we are going to set 4096. We can activate ambient occlusion and proceed to bake. It will start calculating. Here we have a progress bar that indicates the status of the calculation of each of the line maps. This process will take a little longer than usual because they are 4 lighting states that it has to calculate. And when it finishes, the lighting result of our scene will be correctly displayed. Do not worry about the visualization during the process. Okay, here we have the result. The skybox. Let's rotate it a little bit. Let's rotate it a bit. Let's see, so it can be seen. Something like this. We have a light volume applied to the scene to slightly improve the visualization. And here we have the result. If we come into the tool and we do the intercalation between the different lighting, so we see that, is there a change? Consistent in the scene lighting. Here we can adjust in the states, and we can quickly come to the states over here, through the bar. From Tools. Here we can close it and open it from here. And here, we see that in state number 4, and the skybox is make it practically black. Here with a fairly low lighting value. Here state number 3, well, a bit the same. Yes, make it practically imperceptible. And state number 2 and number 1 I think they're fine. And so, when we do the interpolation between the states, here this can be a little more reddish, a little less intense. And this is how our scene would be correctly configured. Our scene is also compatible with Unity's timeline, which we can find here in sequencing timeline, right? And we can create a timeline, assign it to the scene, and let's unlock it here, and we have 2 ways to do it. 1, right-click, create live fusion track, and then assign our LightMap Fusion controller, or directly drag it over on the timeline here, assign my fusion track. Then, for each of the states, we right-click, add live multifunction track. And when we add it, we can see the following, that when selecting it, a track is created here, which we can right-click and create another, and put it in another state, for example, this one. Can the states be? They can be mixed together. We can duplicate them. Here we are going to assign it different values. Other values, for example, and we duplicate and set this to, well, other values. Let's mix between states. We can control the duration of the states here, also here, and the blending. Let's check how given when we press play. Well, we see the interpolation between the states, and for example, and if we put it on loop, when we get here to the end, it will repeat. Our scene lighting. The tool can also control the emission intensity of the tool's materials. For example, if we look at the lamp, or the ceiling lamps, how its emission intensity also contributes and changes, because it has an emission parameter for each of the states. And well, this is the end of the tutorial on the LightMap Fusion tool for